think about 3D printing and the future of where it's going in the field of architecture is both interesting and exciting, especially from the growth and innovation we have seen in the industry over the past few years. So much that it makes it challenging to keep up with all of the exciting work we have seen from companies and individuals like Icon, who are 3D printing affordable housing in Austin, Texas, Branch Technology, Apis Core, Emerging Objects, and the work at ETH Zurich, to name a few. We also see additive manufacturing, or AM technology, providing companies with a more sustainable way of producing both socially and environmentally. I think it's safe and easy to say that 3D printing is no longer seen as just a prototyping or model producing method. And as printers continue to scale up and have the ability to print more unique and architectural materials and integrate both automation and AI, we're only beginning to see the true opportunities that technology has to offer in solving the problems of the future. I think for architecture to get there, we have to learn how other industries are incorporating the technology into their production processes. Currently, 3D printing is becoming mainstream across all major manufacturing areas, especially those like aerospace and automotive companies, where the products they are making through typically traditional manufacturing methods and have a high number of unique parts which require large factories full of expensive tooling and skilled labor. So once they begin to introduce 3D printing to the baseline of the manufacturing process, you will now have a more flexible tool than a fixed tool. And that makes it easier to change, modify, and update designs in a current and future production run. This will ultimately reduce costs and provide a faster and more efficient workflow. So, what are some of the predictions of the future for the technology? There are many experts and people in various industries having these discussions, and a few that I think are important and relevant are, first, 3D printing will need to become a mainstream technology for serial production. 3D printing has long since moved past being viewed as a prototyping solution. Everyday companies are finding ways to incorporate the technology into their production, from tooling, replacement parts, and even building components. From automotive, aerospace, building, and consumer goods, companies are becoming aware of the advantages of 3D printing to the production line. According to a recent 3D printing report, 51% of companies are actually using 3D printing in production. Specifically in the auto industry, major auto manufacturers are producing usable parts for the vehicles. For example, BMW recently announced its 1 millionth 3D printed part for its i8 Roadster. While the number of printed parts is low when compared to mass manufacturing volumes, the key to future growth will be to maintain momentum and commitment of developing technology and applications at a larger scale. I do not see 3D printing becoming a replacement manufacturing process for, say, casting, machining, or molding, but it will certainly be interesting to see how it will become a viable and reliable production method that can be used with other technologies. Second, I think more education and training will better help with the adoption of the technology. This does not only apply to the future workforce that is currently in school, but an investment in the existing workforce as well. In addition, I think 3D printing will need to become smarter in the future. We should anticipate that the industry is on a quest to improve printing efficiency with smart technology. Hardware manufacturers will and are fitting machines with sensors and cameras that can measure various aspects of the build in real time, which helps with part documentation. Companies are integrating machine learning algorithms with sensors to aid in a smarter printing process where data is gathered from the sensors and fed to the machine learning algorithm, and the results will provide feedback to an engineer for how process can be improved. The information can also be used to predict part defects or build failures that can be communicated while parts are in production, and engineers can intervene in that process and eliminate any errors from happening. Many materials such as concrete, ceramic, and plastics have been widely used for some time now and have many advantages for their low cost and diverse use, but it's the research in metals and composites that need to continue to improve and grow. When you read about the state of the metal printing industry, you will understand that it's not only one of the fastest growing areas, but an area that is far from reaching its potential. An interesting company like EOS, is revolutionizing the metal industry to support higher volume of printed parts and even adding materials like stainless steel, aluminum, and grades of titanium. Once metal 3D printers become more reliable, faster, and with more material options, we can anticipate huge growth and opportunities in this industry. Composite 3D printing will also offer a huge opportunity. Perhaps the newest segment in the 3D printing field, composite printing is highly sought after in aerospace, automotive, and many other industries due to its lightweight and strength properties. Industry analysis suggests that this will be a $10 billion industry and will help reduce cost and time of traditional composite manufacturing processes. Companies like Markforged and Fortify are big players in the market, especially for small, affordable parts. But it's the work of Thermwood that's really exciting with their large format printing systems. You may have seen recently with their hybrid large format printer, they successfully printed a full-scale usable boat body, which was printed in multiple parts and then glued and laminated together. Another key focus will be on automation. Automation is really the next step in the evolution of additive manufacturing, achieved through a combination of hardware and software, as well as robotics, sensors, and networks. Automation will ensure more streamlined processes as part of an end-to-end digital production cycle. On the hardware side, companies are launching new integrated production units which incorporate robotics and smart factory concepts to automate various steps of the workflow. On the software side, post-processing will become one of the major sectors to watch out for. Automation will allow companies to transform 3D printing to a continuous process that will work much better in a volume production setting, which 3D printing does not quite have the capability for at this time. Okay, so with that said, I think there are some very interesting companies and institutions to keep an eye on. Many who are starting to implement a lot of these processes and ideas into the workflows, such as Icon, the Austin-based company, Branch Technologies out of Nashville, Tennessee, and the ETH Zurich, whose project Smart Slab is really making a great and important step forward, putting structurally optimized and geometrically complex concrete formwork in sand. They use a large format binder jetting 3D printer. One of the advantages for this process is addressing the most resource intensive process in concrete construction, which is fabricating the formwork. Another advantage is the ability to have more performative slabs that use less material due to optimization of the slab thickness. And then a third advantage is that everything is built and manufactured in a factory and then delivered and installed on site. The second company, Icon, which built the first 3D printed home in the US and was awarded the first construction permit in the world to build homes. The house was printed in less than 24 hours and cost less than $4,000. And the real aim of the company is at solving housing issues and providing an affordable solution for people. They are currently building the world's first 3D printed community of low-income homes for people in Mexico. In addition, they also design and sell large format concrete 3D printers. Their newest printer, called the Vulcan 2, has an expanded footprint large enough to print multiple story homes up to 2,000 square feet and is easily transportable and doesn't require any assembly. It's really the first of its kind. They use their patented concrete material called lavacrete, which is able to be extruded and stand up on its own without any additional formwork to be used. And the last company, and one that really is the most exciting, is Branch Technologies. Branch Technology is kind of inventing a new way to build by providing an alternative to FDM printing processes when scaling up printing for the construction industry. Their process, which does not require a large machine to be transported to a job site, uses robotic arms in a process they developed called CFAB, or cellular fabrication. This process allows for freedom of 3D printing parts using a 3D printed material comprised of fiber-reinforced polymers that solidifies in free space without the need of any support material. The advantage is that it removes kind of geometric and material limitations typical of FDM and uses up to 20% less material in the process. Their production process can easily print parts larger than the printer itself, and they have become the first company to successfully 3D print interior walls to scale, with the production utilizing a space-filling lattice structure that are lightweight, strong, and reduce material at the same time. Their advantages are prefabricated parts which yield higher quality of finished parts, built in a controlled environment, and the accuracy of robotic arms. An additional unique advantage to their system is they apply and use other economical and known construction materials to make a wall assembly, for example. Once all the materials come together, it has a composite effect that functions like a real wall, but is actually much stronger. The company has printed numerous installations and prototypes to date, and recently they constructed one of the world's largest 3D printed structures using only a composite material. The structure stands at over 6 meters in height and 14 meters in width. So I think it's kind of really safe to say that, there's a lot of really important trends, companies, researchers, all who are really sort of shaping the future of 3D printing in architecture and other industries. And so I think it's, safe to say that we are closer to living in homes and cities that will be completely 3D printed in the near future. Okay, not only do I think it's possible, I think it's already happening and happening in a big way. When it comes to 3D printing in space, there are really three potential areas where 3D printing can be beneficial. One, fabrication of spare parts. Two, construction of space structures and habitats. And three, the preparation of food. So when it comes to the fabrication of spare parts, this is an area has been ongoing for some time, maybe 6, 7 years, and was shaped by a company called Made in Space. So Made in Space is a small startup who built one of the most advanced 3D printers. Their idea developed from the challenge that it cost upwards of around $10,000 per pound to send material into space. What they realized is that there are also large amounts of spare parts on the space station, just in case something happens. This led to their idea to be able to print on-demand parts in space and develop a printer for the space station that utilized anti-gravity technology. A few years ago, in 2014, they successfully printed for the first time a part in space. And it was the first part actually manufactured in space. This sort of new ability to 3D print parts and tools on demand dramatically reduces the time it takes to get parts to orbit and increases the reliability and safety of space missions while decreasing costs. So kind of current space missions take months to years to get into orbit. With 3D printing, parts can be built within minutes to hours. So once they kind of began to realize all this and they had a lot of success, now what they understand is that it really doesn't make sense to fabricate on Earth and launch parts little by little into space. This set up the next project called the Archinaut, which is a floating robotic factory that will 3D print and assemble large structures in space. The benefits of this future project will build in-space structures for a fraction of the cost and lighter than what is necessary to launch currently from Earth. Additional benefits will be to launch raw materials into space and print on demand and needed parts and structures that could be a viable solution for getting us to Mars and to other planets. Printing in habitable structures might be the most interesting from an architectural perspective. David Mallet of the company AI Space Factory explains that building on another planet is not just a design or technology problem. It is a construction problem. Engineering, material research and development, and autonomous manufacturing techniques will need to be brought together to construct beyond Earth. As I mentioned before, there's a huge cost associated with sending materials into space, but one possible solution according to AI Space Factory would be to launch robotic rovers capable of constructing on the planets they land on and from the materials that exist on that planet. Autonomous construction could and would allow them to build structures layer by layer without the need for humans to be on site. Their NASA award-winning project Marcia proved that it's possible to build on the surface of Mars. Marcia is a future Mars habitat that is a 3D printed multi-level structure. The material is comprised of a material that is available on Mars and constructed with a robot which they developed and they believe will be an autonomous process. It is one of the first proposals that builds above the Mars surface, which is a challenge due to a high amount of radiation on the planet. An interesting project nonetheless, but in order to print or build habitats on another planet, it will first be necessary to build surface infrastructure, such as landing pads, roads, and hangars that can support landing heavier rockets and equipment. As we get closer to understanding how to inhabit other planets like the Moon and Mars, it's safe to say that 3D printing will play a critical role in allowing us to do that, whether it's 3D printing parts here on Earth, manufacturing and assembling in space, or constructing habitats on Mars. Which leads me to my next company, Relativity Space, who is actively pursuing novel ways for 3D printing 95% of a rocket, which they view will be the next big disruption in the rocket industry. Relativity Space is on a path to change the rocket industry, where typically rockets have 100,000 parts and take years to construct. They are trying to do the same with a mere 1,000 parts and with only 60 days of printing. They have already successfully printed and tested a rocket engine in only 3 parts, compared with traditional engines which can have up to 3,000 parts. To date, they have successfully tested over 300 rocket engine tests. They've been able to do this by building one of the world's largest metal 3D printers, comprised of 3 robotic arms and called Stargate. Stargate works by having one robotic arm connected with a deposition head where aluminum alloy feeds layer by layer, and the other 2 robotic arms simultaneously perform post-processing and inspection functions like handling tank polishing, surface removal, checking for abnormalities, and quality control on finished products. The advantage of printing fewer parts is obvious. Not only does it not reduce manufacturing time, but it also produces parts that are more reliable. Obviously, there are a number of advantages that 3D printing has over traditional manufacturing and machining methods. However, as with every method of production, 3D printing also has its issues and drawbacks. First we can outline some of the advantages or pros of the technology. There's freedom of design, meaning that printing affords the ability to produce complex geometry that machining and injection molding may struggle with or may simply not be able to make. Sometimes part geometries have complex geometry impossible to be machined or removed from a mold. AEM makes printing complex geometry possible through various printing processes and support material. Rapid prototyping allows for parts to be produced in hours instead of days, which reduces overall cost and greatly increases speed of the design and iterative process. Printing on demand, which is important where inventory cannot be stored. Printing on demand follows the just-in-time inventory management method, and rather than producing in bulk, it will free up inventory, it'll free up financial assets, and because all files exist digitally, it is easy to go back through your library and print a new part when you need it. You can print lighter and stronger parts. Through optimization and material selection, it's possible to print lighter and stronger parts than traditionally fabricated parts. In industries where fuel economy is important, lighter parts are an advantage for better fuel economy. There's waste reduction, which means a more sustainable process of fabrication. So since printing is an additive process, you only use the material needed to produce the part, as opposed to machining, which cuts away large chunks of often non-recyclable material. This will ultimately reduce the cost of a part, since you will only be paying for the material used instead of paying for the waste also. You could imagine that 3D printing will be more cost effective since you have one machine that does multiple processes and reduces the amount of energy instead of a multi-step fabrication processes, which use multiple machines and a lot of complex labor. And lastly, accessibility. As 3D printing grows and becomes more widely used, its accessibility also increases, meaning that you can often find a local or nearby servicer if you choose to outsource your 3D printing. This will likely save you time on transport and cost, as many traditional manufacturing methods are still produced abroad. 3D printing also has its issues and challenges. There's limited materials. 3D printing is not yet versatile enough to work with most materials. Various plastics, metals, and concrete are available, but there are limited options that are easily recyclable and, for example, food safe. There are limited binders for powder-based materials. Another issue is limited build volumes. Although this is rapidly changing, there have been many advances in increasing the scale of production. This is not yet common across the industry. Having to print parts in sections and then post-process by gluing or some other method of post-production is not ideal. Post-production is a common issue across all printer scales, materials, and formats. Post-processing is typically required to remove support material and smooth the surface finish. Additional machines are also typical in the post-production process, such as water jetting, sanding, chemical soaks, assembly, and more. The amount of post-production on a part does vary based on scale, material, and printer type. Part structure is a critical issue and one that plagues many types of material. With AM, parts are printed in layers that adhere to one another during the process. So what that means is that under stress or part orientation, the layers may separate, causing the part to essentially break under any stress. For FDM printing, there is more of a significant problem than other types of printing, such as SLS. Polyjet parts are solid in their material composition, but the results can be very brittle. So delamination of parts, brittle parts, and nozzle extrusion inconsistencies can be common issues that can have a negative effect on a part structure. With the perks 3D printing brings, we might be entering a new post-industrial manufacturing age, where products are built faster and are significantly cheaper than ever before. However, this printing technology also has its own set of drawbacks that should not be ignored, better understood and mitigated. One thing is certain though, 3D printing's technology and market share will increase, and there will be a continuous trend for customization in the future.